when I say that the von Neumann entropy of a single particle is the entanglement entropy, we're assuming that the composite system itself is a pure state. So we're assuming that this composite system up here of a two-particle system itself is a pure state. And when you take one particle and trace it out, then what you have is a mixed state.
Mm-hmm.
And so the problem is that when I construct the purifications, there are many pure states that could have produced it. There isn't a single pure state. There are many of them.
Yeah.
Which means that because all of these pure states can produce the information you have in the mixed state after doing the partial trace,
Yeah.
because there are many of them, then you are ignorant about which one actually constructed that thing.
Yes.
And so so if there's 1,000 pure states versus 1,000,000, if there's a bunch of purifications that could have produced that, if there's 1,000,000, then you're way more ignorant about which one, if you had to guess at random, than if there were only 1,000 or 100. You have a 1 in 100 chance of guessing the right one. If there's only 100, you have a 1 in 1,000, you have a 1 in 1,000,000. So the more pure states there are, the more ignorance there is.
Yes.
And so what I did in my research is I was like, okay, let's take this thing and let's construct the manifold of all the purifications and then compute that thing's volume. And it's essentially like a smaller volume like having 100, a larger volume like having 1,000, and an even larger volume like having 1,000,000. So what that's telling you is that within the composite Hilbert space, because you constructed a composite Hilbert space out of the two smaller ones, within the composite Hilbert space, there is a set. And there's a set of purifications that when I take the partial trace, give me this mixed state. And so the information that distinguishes that set are all of the pure states such that when I take the partial trace, they map back down here. So that's why you have this one thing, you have a branching out.
Yeah, here. And you said there could be many purifications.
Yes.
Okay, and then...
And so what this means is that what I found is that if you have a pure state that's already a pure state, so you have the space of the composite of the Hilbert space, and then I have the single Hilbert spaces. So I'll ask you, what do you think the volume is for a state that's pure in the single Hilbert space? When I look at its volume in the composite Hilbert space, what do you think its volume is if it's already pure in the single Hilbert space?
No idea.
It's 0. It's already pure. You can't purify it. The process of purification is to construct all of the pure states that map back down to the state in the single Hilbert space.
Okay. Yeah.
So if it's already pure down here, then there's nothing to construct.
Yeah. Okay.
So it has 0 volume.
Okay.
But as the thing becomes more mixed, as you move away from purity and it becomes more mixed, then the volume grows monotonically. And so you can go from pure and continuously change the state by adding more mixedness until the volumes grow until it gets to a maximally mixed state in which the volume is maximal.
Okay.
And so what that tells you is that the volume is telling you about a measure of entanglement. And what's happening in the composite space is, remember, the composite space is consistent of a set of things. I have a set of purifications that map down to a mixed state. And so imagine that down here, and this is a triangle. So in my notes, I have a triangle which represents the single particle Hilbert space, and the vertices of the triangle represent pure states, and anything that's not on a vertex are mixed states.
Yeah.
And the center of the triangle is a maximally mixed state that has no information in it. And so if I were to look at a trajectory, for like a curve on this triangle from a vertex to the center of the triangle, then what I can do is along that trajectory on that curve in the single particle space is there is a corresponding trajectory in the higher dimensional Hilbert space.
Yeah.
Because remember, at each point on that curve, I can construct a manifold of purifications.
Yeah.
And so what that means is that the composite space itself gets coarse-grained. It gets constructed into a space of disjoint sets, where each set corresponds to a point down here. So for every point down here, there is a unique set of purifications that map back down.
Yeah, I understand that, yeah.
And so what that means is that when you're looking at the state itself, and it's going from a trajectory of a pure state to a maximally mixed state, then the composite Hilbert space, it's moving from purification manifold with smaller volume to larger volume. And this is important because this is the nature of the second law of thermodynamics. This is the arrow of time. And this is exactly the argument that Boltzmann made when he was trying to prove his H theorem to mechanically derive the arrow of time, why entropy always increases.
Yeah.
Because these things up here, these purification manifolds, they represent entropy. They are ignorance. They represent the amount of ignorance.
Yeah.
And so what I've done is I've created a coarse graining of the composite Hilbert space that separates it into a bunch of disjoint sets, where each set represents the set of purifications associated with the density operator in the base space.
Yeah.
And so what this means, if you're asking what all this means, is that this trajectory of it going from a pure state to a mixed state can describe an entangling process. Because remember, when something is pure, it's separable. It has no correlations. Decoherence is when it starts to interact with its environment and starts entangling with it. And so when it starts entangling with it, then that purity is starting to be lost and it's starting to become mixed. And so we can get into what this means in terms of information, because it's actually pretty subtle, this next argument. But just now understand that as I go from a pure state to a mixed state, due to the fact that a pure state is entangling to some larger system, then the ignorance that's happening is like the purity of the information is bleeding into the other thing. It's like you had that separate piece of paper that was separate, and then the information starts to mix in, it starts to blend together. And so that mixing results in a trajectory of going from, in the composite Hilbert space, from macro states of smaller volume to macro states of larger volume. So what I've constructed is a description of the arrow of time, of thermalization, purely in terms of entanglement.
Okay.
Does that make sense?
I have to collect my thoughts.
Just ask whatever question, just ask any question, just whatever comes to mind.